Well, howdy, you flea-bitten varmints. This video tugs on my heartstrings because it's the first video where we're going to be reviewing a printed circuit board designed for the iSpindel, designed by myself. Yee-haw! Welcome to Open Source Distilling, where time-honored tradition meets modern-day technology. Stick around until the end of this video to learn how you can be entered into a draw to win the iSpindel prototype featured in this video. This is not a sponsored video, but PCB did send over the circuit board prototypes for free, and I'm going to give my honest opinion about them. From the time that I submitted my files to the time that the circuit boards were in my hands was less than a week, and I did find that quite impressive. The circuit boards seem like they're very good quality, and I didn't run into any issues during my prototype build. The main point of this video is to show you the prototypes that I currently have, to show you the 3D render of the Jeffrey printed circuit board 2.0, which is the newest design, and I need help from each and every one of you to give me suggestions on how to make the circuit board better. When I built my first iSpindel, the battery holder was of big concern to me for a few different reasons. The battery holder was not movable, and we'll get back to this point later in this video, but on my circuit board, the battery holder is movable, and that's why we see some slits in the circuit board. The circuit board from my previous build only accepted keystone battery holders, and that's an issue for a couple different reasons. Number one, keystone battery holders are not super widely available, and they are very expensive for just being pieces of plastic with a little bit of metal. I wanted to approach my circuit board build and make it so it could have essentially a universal battery holder acceptor. My circuit board won't be supporting any battery holders with wire leads coming off them, and it also will not be accepting this specific battery holder either. I was able to clip the plastic on these to make them low profile so they would fit inside the pelting. The real issue about this battery holder is, well, a couple different things. So unfortunately, when the battery is in there, it's actually elevated just a little tiny bit, and that is due to the thick bottom, plastic bottom on this battery holder. This raised up the circuit board just enough that it really didn't fit very well. This required me to file down the circuit board itself, but also the D1 Mini. And during the process of filing down the D1 Mini, I somehow destroyed my iSpindel. It would no longer work, and when I hooked it up to the Arduino serial monitor, the D1 Mini was giving all sorts of errors and wasn't able to connect to any of the other components. So I can't recommend that we use this battery holder. The official keystone battery holders are going to be supported, and that's the through-hole and surface-mounted battery holders. But what I'm going to recommend is this essentially a keystone knockoff, and I'll leave a link down below to my blog post where we'll have a link to this product on eBay and possibly Amazon as well. I'm going to recommend the surface-mounted battery holder over the through-hole, and that's really just for the ease of adjustment later on when we're moving the battery holder up and down. The position of the gyroscope also turned out to be an issue. What happened was the gyroscope and the D1 Mini were too close together, and I had a problem getting the USB to plug into the D1 Mini because of the things being just too close together. I was able to finagle things around with the prototype enough to actually get in there and flash the firmware, but moving forward we're going to move the gyroscope towards the bottom, and it won't be an issue on the next build. I did also consider just flipping the D1 Mini upside down so the USB port would be pointing upwards, but the aerial would be further down, and water and Wi-Fi signals don't really play well together. So really, this is the best position for the D1 Mini to make sure that we get the strongest Wi-Fi signal available. And just to be clear, this is a fully working prototype, and it floats at 25.33 degrees in pure water. Now let's hop over to the 3D render on my computer. I introduce to you the Jeffrey PCB version 2.0. He's a nice bloke from down the road, isn't he? This is the front side, and I've only included the pins on the D1 Mini that are actually required to be soldered. I've included some silkscreen guns and some messages, and I wanted you guys to have things that essentially got covered up that only you knew about, but that would make assembly just a little bit more interesting and fun for y'all. There is a shallow solder point to avoid a circuit on the D1 Mini. And one thing I was missing from my first build was a place to number my iSpindel, so I've included a little tiny white label here for you to use a felt pen on. We have some branding, and as you can see we talked about before, the gyroscope has been moved to the bottom. And guys, I just love each and every one of you very much. We have the temperature probe, and at the bottom we have a diamond because you guys and me were forever. This perforated area at the bottom is to add some weights. I used number 10 screws from Home Depot, and I used some double-sided Gorilla Tape to affix them. These nuts weighed about 3 grams altogether. Now let's flip it around to the backside. On the top we have 2 bumps. They have holes drilled in them. My previous iSpindel build got stuck inside the pelting, and I actually had to go in there with needle nose pliers and pull it out forcefully, and I wanted to provide a safer way for everyone to get the iSpindel out in case it gets stuck in the pelting. So these holes will accept a pen, and you can just use these holes to essentially lever out the circuitry for the iSpindel. Another thing is I never knew if my iSpindel was turned on or off. So I've made one bump on each side white. So when the switch is towards the white side, the iSpindel's on, and when it's toward the other side, the iSpindel's off. And pay no attention to this white rectangle over there. That side is going to look like the other side, but it's just going to be white. On the sides of the circuit board, there's these little tiny bumps with 1 millimeter markings. And there's actually something similar at the very bottom as well. This circuit board is designed not to fit in the pelting, and you actually have to file these points down to make sure you get a real snug fit. The iSpindel is very sensitive to movement, and I don't want the circuitry moving around once it gets inside the pelting. On my original build, when we installed the TP4056, I had to bend the pins in order to get it to fit together. So my TP4056 footprint has been updated, and I can confirm that you can install the lithium-ion battery charger without having to bend pins and kind of forcefully get things into position. Underneath the battery charger component, we have the resistors and the diode. Now, we have a 230 kilo ohm resistor, and personally, I just haven't been able to easily find those resistors, and I ended up using a 220 and a 10 kilo ohm resistor. So this V shape here is really so you can take 2 resistors, put them in V formation, and get your 230 kilo ohms of resistance across the combination of these resistors. We have the reset pin on the side, and it's offset from the D1 Mini's through holes. So if you end up mounting this upside down, it will be obvious you won't be able to install the D1 Mini. And now we're on to the movable battery holder. I've put a millimeter ruler here for reference, and the idea behind this movable battery holder is that we want to be able to get the iSpindel to float to about 25 degrees in pure water. In my previous build, the amount of weight I needed to add in order to get to that point was so much weight that I actually sunk my iSpindel. So I wanted to provide a way that we could adjust that tilt value in pure water without adding too much additional weight. With the 3 grams of nuts on the prototype, the position of the battery was somewhere in the region of 6.8 millimeters on the ruler, and that's right in the middle of the full motion of where the battery could sit. Again, this battery holder will accept the official Keystone battery holders, and also probably, I think, most of the knockoffs available. I really do recommend the surface-mounted battery holder, as it will make the adjustments easier later on. We have some text here about some website information, my official opensourcedistilling.com webpage for the iSpindel, and also the official webpage for the iSpindel. I've also included a message for you guys that's going to get covered up during assembly, and I just wanted to say thank you to all you guys out there, all you dirty varmints out there that support me. I really do appreciate each and every one of you, and I do love you guys very much. You may also notice that the sides of the iSpindel are sucked in a little bit, and that's just me trying to cut down on the amount of friction so it's easier to move in and out the circuit board from the pelting. What I really need from you is suggestions on how to make this board even better. Please, please, please let me know the improvements that you want to see. In 2 weeks, I'll be giving away this prototype that's featured in this video. In order to be entered into the draw, you need to be subscribed to my YouTube channel, hit that bell icon, and leave a comment in this video down below. The iSpindel will ship without the lithium-ion battery, but otherwise it will be a fully functional and complete iSpindel. Please share this video with your friends that may have feedback on how to improve on my design. Listen guys, thanks for making it to the end of this video. Really do appreciate it. If you have any feedback about the printed circuit board design, please let me know in the comments down below. I want your feedback and I will consider it all. I love each and every one of you very, very much.